Hey, welcome back. In this lecture, I want to introduce C strings, which are from the C language. To get started, I have this console output statement. I'm printing out this string literal hello human. If I build around that, we get hello human printed out. Of course, I also have this final statement here in the program. As I discussed in the module C++ 101, the string literal is basically a container or a null terminated array of characters. If I do Ctrl-K, Ctrl-I to get more information on that, we can see this is an array of characters, okay, which are const, and we have hello human in that. Also, if you count the characters, we actually don't see the null here, but it is in there. So if you count the characters, you will see you have one or less character in there. We have 5 characters, plus another one for the space, then we have another 5 characters, and plus one for the exclamation. So that is going to be 12 characters, not 13, and that's because this character array is actually terminated by the null character. Okay, so that null terminator is basically used as a sentinel for certain functions that are going to iterate through the array of characters. Now I'll get back to the null a bit later. What I want to discuss here is the fact that this is now a literal. We basically want to create a variable, write some string that we can reuse. Since you already have a familiarity with object-oriented programming, we also have the C++ string, which is going to be a class with overloaded operators. But we'll discuss that later on in the lecture. For now, we stick to C strings. And to get started, let's go and create a character array. Also notice sometimes I get a sort of error here. This is a false positive. Cout is ambiguous. This will actually build fine, so we don't have an error with that. That is referred to as a false positive. Now what I can do is, I can actually just remove this using namespace. Now I'll have to make sure to fully qualify console output and endline with that standard prefix. And that's fine, that is basically how you should be doing it. Of course, using namespace at the top just makes it easier, but this is basically how you should do it in any way. So in some of the upcoming lectures, I'll be using this format from now on because that is basically how we should be doing it. Apart from the next lecture, because I actually recorded that before I did this lecture. But in any case, let's continue here. So I have this character array, x, y, and z. You can see currently it is not terminated with a null. So it does not have that sentinel which functions can use, which will then iterate on this. But I can still print it out manually, so if I go and do, that is an array with 3 elements. So of course we can iterate through the character array in this way now. We can go and print out each character. Actually I don't want the end line right here. Alright, so if I build one now, we get x, y, and z printed out. But one issue with this is we have no indicator to where the character array ends. Remember I discussed sentinels in the first module, C++ 101. So with C strings we actually have a null terminator at the end. And with that we don't have to keep track of the size of the array. We can just use that sentinel. When it reaches the sentinel, of course it's going to stop iterating through the array, printing it out or whatever we are doing. One example on why this is important is the stream insertion operator is actually overloaded to work with character arrays. As you can see right here, we don't get an error. But you'll see that this does not give us the results that we expect. We expect x, y, and z printed out. And if I build around this, well, look at all of those characters that we get, all of those weird characters. And that is because it is not null terminated. It does not have that sentinel. So the function that operates on that array does not know when to stop iterating. So let's look at a different example where we actually have a proper C string. What is the null character again? It's not null pointer or O or 0. It is \0. Not \O, it is \0. And now we can print this out. Now we can call this whatever you want. This is just for demonstration. So we can see that this is now a proper C string. It is null terminated, and now the iterator will understand, okay, it reaches that sentinel, it reaches this null character, and it will stop printing those out. So build and run, and we get x, y, and z as we would expect. Of course, we have libraries of functions which also operate on C strings, and we'll look at those later. Okay, a couple more notes on C strings. If you remember back to the module C++ 101, I mentioned that with list initialization with arrays, that the elements that we do not explicitly initialize will get initialized to 0. So for example, let's say we go and declare the C string with 5 elements, and now I can go and remove the null at the end, and this will actually work fine because it's going to append 2 nulls at the end. I can build around that and you'll see that will work fine. And the same thing with 4 elements, because we'll have a single null at the end. But of course, if this array has 3 elements, then this will no longer be a C string, because it is not terminated with null, and we'll get a bunch of weird characters printed out here that we do not want in our C string. It will basically print out garbage until the iterator reaches a null character. Also, I'll just go and remove that. We can use a string literal such as down here. Let's say we have hello human. Remember I mentioned that this is a string literal. Now we can use that to initialize the C string as well, and that is the preferred method of initializing a C string. Build a run and that will now print out hello just fine. And you can also add spaces and everything. Exclamation as well, you can see that works. Hello, we get a space. It prints out the entire string, as we would expect. Okay, let's summarize what we've discussed in this lecture. We have the character array declaration and initialization. This is an array of characters, but it is not a null terminated string, and so it is not a C string. The C string or null terminated string has the null character right at the end. That is the final element within the array. The C string is originally from the C programming language. It is also an array of characters, but the null character is used as a sentinel to terminate the C string. Functions that operate on C strings will expect the null character. Those functions will typically iterate through the array of characters, and they'll use the null character as a sentinel, so iteration will stop. For example, if you don't have the null character, you'll keep printing random characters or garbage until the null character is reached, as we've seen in previous examples. And of course, to avoid that, we terminate the string with the null character, and iteration on the C string is then terminated when the null character is reached. And finally, on C string declaration and initialization, we can initialize a C string using characters, but the preferred method is to initialize the C string using a C string. You can see in the final example I use a literal C string to initialize our C string.